Geometry OST Spring 2023 released state test items number 12. It says a hot air balloon is launched and drifts over a boat. The boat's altitude increases at a constant rate. The balloon is directly above a boat 400 feet away from the launching point 5 minutes after it is launched. The angle of elevation is 72 degrees. Here is the figure describing that. So the question is, what is the change in the altitude in feet of the hot air balloon each minute? Round your answer to the nearest foot. Okay, so it says that the balloon is directly above a boat 400 feet away from the launching point 5 minutes after it's launched. So what has happened here is in this picture, we have a hot air balloon and it's gone up, right? After 5 minutes, it has an angle of elevation of 72 degrees and it's at that point. We want to know what is the change in altitude of the hot air balloon each minute. So here's what we have to do, right? We have to find this altitude, and we're going to do it using trigonometry. SOHCAHTOA. The reason I know this is because I'm assuming the hot air balloon is going straight up. That's a right angle, and I have an angle and a side length. So we're going to use SOHCAHTOA, which is on your reference sheet, to find the altitude. Once we find the altitude, we're then going to divide it by 5 because we want to find out, right? The change, the rate of the altitude in feet each minute. So feet per minute. Okay? All right, so let's grab this reference sheet and let's show you how SOHCAHTOA works. So here's SOHCAHTOA, right? Sine, opposite hypotenuse, cosine, adjacent hypotenuse, tangent, opposite adjacent. So what I will do here is I will label this triangle using this 72-degree angle as my reference angle. So I'll draw an arrow across. That means X is what we call the opposite side, and I will use it. The right angle points to the hypotenuse, which is this side. I don't have any labels. I don't need to use it. And then the third side is called the adjacent side, and I will use it. So I am using opposite and adjacent. I am not using the hypotenuse, so I'm using tangent. So this equation looks like this. Tangent of my angle, and my angle is 72 degrees, equals the opposite side, X, over the adjacent side, 400. When you solve this, always start by multiplying by the denominator. So we're going to times by 400. Now what's going to happen is X will be all by itself. That's great. And we're just going to type this into Desmos all at once. 400 times the tangent of 72. Now when you do this typing in, you have to make sure your calculator's in degrees. To check that, use the wrench. It should be in degrees, and mine is. You see degrees right there? So we are in degrees. So I'm simply going to type out 400 tangent of 72. And I get 1231.073. So I'm not going to round that, right? So what I need to do now is I have to take that altitude and divide it by 5 minutes to see how much it's rising each minute. So 0.07341487 divided by 5. And there we go. And that is going to be my rate that I'm rising at, 246.2. And that'll be my answer, 246.2. And again, it says how many feet, but it's asking for, how many feet is it rising per minute, which is essentially the rate, 246.2.